All right. Good morning, students. Good morning, everyone. Okay, welcome back from your long weekend break. I hope all of you have sufficient rest. So today, let's continue on what we have learned the other class. Okay, recap on what we have learned previously. So first of all, we learned about Dalton's law. Okay, so we have Dalton's law of partial pressure. Okay, what does Dalton's law of partial pressure says? Tell me anything that you remember. Okay, ideal gas, they do not interact with one another. Okay, so they don't form bonds with one another. That's the meaning. Okay, they don't interact with one another. Okay, what else? What about their pressure? Okay, the total pressure is equals to the individual pressures added together. Okay, so in another word, I can also say that, okay, number one, ideal gases, they don't interact with one another. And number two, okay, they exert. Exert means they give out. Okay, they give out their own pressure. Okay, regardless of other gases. That is why total pressure is the addition of all the individual pressure. Okay, next we learn about kinetic theory of gases. There are four, I think, okay. What are the theory, okay, that we outlined about ideal gases? How do ideal gases behave? Okay, negligible size, okay? If you cannot use negligible, this word, you just say the size is too small, the size is not significant. Okay, so size is too small or very small. Okay, what else? Constant random motion, okay? They move in constant random movement or motion. Okay, what else? Elastic collisions. Okay, it means that when they collide, okay, with one another or with the wall of container, they gain back the same energy. Okay, elastic collision. And lastly, okay, insignificant or also the word negligible force of attraction, or you can say, okay, no force of attraction. Okay, so this is what we meant, okay, ideal gases, perfect gases in theory. Okay, by theory, how do they behave? So these are the 4 points. And then next, okay, how ideal gas becomes real gas? Okay, we have two things. One, we call it ideal gas. So ideal gases means the gases in theory. Okay, 100% perfect gases. And then we have something called real gases. Real gases means those that are actual. Okay, in life, how does the gases behave? All right, for ideal gases to become like real gases, it means that my gases no longer fulfill my kinetic molecular theory. Okay, it's no longer negligible size. It's no longer constant random motion, no longer elastic collision, no longer negligible force of attraction. So under what conditions, okay, does my ideal gases become like real gases? Okay, high pressure. Under high pressure, what happened to the volume? Small. So when the volume is very small, what happened? Okay, size cannot be neglected. Okay, size becomes significant, or you can say size of the gas becomes large. Okay, because the volume is very small, so the size remains the same, so it becomes significant. Okay, second, temperature. Low temperature. So what happens when low temperature? Kinetic energy also lesser. So what happens if I have lesser kinetic energy? I cannot move randomly, okay? I cannot move constantly. I don't have enough energy. And when I go towards, okay, from one gas with another, when I go past each other, there's a force of attraction, just like magnet. Okay, when I go past one another, there's a force of attraction. If I don't have enough kinetic energy, I cannot break, so they will be attracted. Okay, so you can also say that there is significant force of attraction. Okay, why? Because not enough kinetic energy to overcome. Okay, so on the other hand, okay, for real gas to become more like ideal gas, okay, of course, right? Once you know one of it, the other is a total opposite. Okay, so in what condition your real gas will become ideal gas? Okay, yes, the other way around, low pressure. So what happens at low pressure? Higher volume. So when you have a high volume, the size of the particle is the same. So what can you say about the size? Negligible. Okay, or insignificant or very small. Okay, what about the temperature? High temperature. Why high temperature? Kinetic energy is high. So can you explain further for me what happens when kinetic energy is high? Okay, the particles, okay, they are able to move very fast. So when able to move fast, we have our constant random motion. And then what about the force of attraction? Okay, when move very fast, even though there's an amount of force of attraction, they are able to overcome. They overcome the force of attraction, so we can say that there is no force of attraction. All right. Okay, so give you guys some time to digest over this. So these are what we have learned previously. Okay, hopefully it's still fresh on your mind. Okay, anything you guys want to clarify or ask? It will be good, okay, if you are able to do your own mind map, okay, on each of the recap. So you do first before we recap, then you will know what points you missed or what point you haven't put in. Okay, in the count of 3, 2, 1. Okay, if no question, we are moving into chapter 2 today. Okay, we are already in chapter 2 in week 4. All right, handphone away. The one beside Ibrahim Horn. Handphone away. Okay. All right. So, sorry, it's the first class of the week again. Okay. So for week 4, okay, the quote for you is, you do not need to compare yourself with other people. Okay. I'm not expecting you to be better than other people. As long as you are better than yourself the previous week. All right. For example, okay, maybe those of you, some of you, you catch up slightly slow. And then you listen to your friends in front. How come they're able to give answers to Miss May so quickly? All right, while I'm still struggling to understand. Don't. You don't need to compare yourself with other people. You want to go out from my class? What's your name? Yes. Huh? Again? What's your student ID? I'll come to you later. I don't want to waste time on people like you. All right. So you don't need to compare yourself with other people, okay? So just compare yourself with what you used to be last week. Let's say last week you still don't get it, but this week you already understand. That is already very good enough, all right? Okay, so we are going into chapter 2. I hope you have downloaded the notes. As explained during the tutorial, for you to download the notes, you have to answer a few questions first. How many of you have downloaded the notes for atomic structure? Very few, okay? I think I'll give you guys around 2 minutes. Those who haven't, please download your notes now. All right, go and download your notes now. You have to answer a few questions in Moodle before you can download. Okay. What does it? Indicator. What are the other words? Correct. I think they try one or no. One or you haven't registered? I didn't see your name in the attendance list today. This morning I just checked. I didn't see your name in the attendance list. Ella, your name is good. Okay. Put your microphone. I think it's yours. You are newcomer, but you don't need to talk on English. Hey, we're going to look at the difference between and. All right, remember to mute your microphone. All right, you guys ready for chapter 2? All right. Your quiz will be in week 8. I know it is long way to go, but your quiz will cover chapter 1, which we have just finished, chapter 2, and chapter 3. All right, so there's no time for you to waste and play around. All right. Okay, so chapter 2 is atomic structure. Okay, first we learn about moles. All right, so the moles where you package together, how many atoms are there? All right, we look at a bigger picture, a whole package of atoms, okay, becoming one mole. Now we are looking into the atom, inside the atom, okay, what is it inside the atom? All right, so learning outcome at the end of the chapter. All right, so we have learned previously that everything around us are divided into, we have solid, we have liquid, and we have gases. All right, and then let's say I have a freshly cut sodium metal. What is sodium metal? Solid, liquid, or gas? Solid. Okay, and then I have a beaker of chlorine. What is chlorine? Solid, liquid, gas? Gas. Okay, sodium metal. How many of you have experimented with sodium metal? See, like you put it in a beaker of water. Anybody has seen sodium metal in a beaker of water? All right, what happens if you put sodium metal in a beaker of water? Vigorously, it's going to jump. Not only just oxidize, but it's going to jump, okay, very vigorously. So sodium metal, can you just eat it like that? No, you're going to die, okay. What about chlorine gas? Can you just inhale chlorine gas? Also, no, you're going to be like toxicated and then you're going to be all yellow, okay. So both sodium and chlorine, they are both very dangerous, very toxic. They can cause death. But then when you mix them together, what is the substance that you form? Salt. A very safe substance. Okay, how does it happen? Okay, it's because of the atoms. How are the electrons arrangement? How are they possible to form a compound? The compound that's being formed, is it ionic or covalent? Okay, and how are they going to form? How many bonds are they? Are they going to share or are they going to donate? So these are what we are going to learn, okay, in the past, in the later few chapters. Okay, we are going to look into the smaller detail, how atoms can form together to form compounds. Okay, so every matter is made up of the tiniest in chemistry. We call it atom. What's the tiniest in biology? The smallest in biology? Cell. Okay, your body is made up of cell. But for chemistry, everything, even cells, they are made up of atoms. All right. So atoms cannot be created or destroyed. It's because it's so small, you can't even see it. So there's no way for you to create or you destroy it. Okay, all atoms for an element are identical. If you remember the first class, I brought you different atoms. And then I say, what happens if this is carbon atom? It will have the same size. All right. And then if you have oxygen, it will also have the same size. So this is what it means. If I have the same element, the atoms will be identical, the same. Okay, compounds form when I have different atoms in a fixed ratio. Okay. Okay, in a fixed ratio, I put the atoms together, I can form a compound. Teacher, what do you mean a fixed ratio? For example, if I want to form a compound sodium chloride, what is the ratio of sodium to chlorine? 1 to 1. You must have one sodium atom and one chlorine atom. That's the meaning of fixed ratio. And let's say if you want to form water, H2O, what's the ratio of H2O? 2 to 1. This is the meaning. Okay, so atomic theory says that number one, atoms cannot be created or destroyed. Number two, okay, for the same element, the atoms are the same. Okay, same size, same mass, same number of proton, electron, neutron. All right. And number three, if I want to form a compound, they will be formed from atoms with a fixed ratio. Okay, so previously we learned that, okay, something that we can see is like this pencil. Pencil is made up of lead. What is the chemical formula of lead? Okay, some of you say Pb because Pb's name is lead. Does all agree that it is made of Pb lead? No. What is this carbon on your pencil made of? C, carbon graphite. Okay, you see, sometimes because the common name is lead and it's called lead, and you thought it's made of Pb. No, it's not made of Pb. It's not metal. Those in your pencil is not metal. I want to ask you something else. Okay, when I was in school, I had friends who will eat the graphite. Any of you have such weird friends also? Yes, huh? Yeah, I don't know why. Okay. But this is to prove to you that it is not Pb, it's not plumber. I'm not sure what happened to my friend after that. We no longer keep in touch, okay? But just to show you, it's not made of Pb. It's just carbon, okay? Another name of carbon is graphite. What else is made of carbon? Yes, diamond. Okay, so when you rearrange an atom, sometimes you get something as cheap as graphite. And you rearrange it again, you get something as expensive as diamond. It's made up of the same atom, just that different arrangement. Okay, so back to here, this is carbon actually, carbon graphite. When I zoom in further, I will see that this carbon graphite is made up of carbon atoms. And when I zoom in the carbon atom, I will see that my carbon atoms are made up of what I call subatomic particles. Okay, remember this is atom. All right, when inside the atom, subatom. Okay, so sub means inside. So we call it subatomic particles. So what are subatomic particles? Subatomic particles are like your proton, neutron, electron. So these are subatomic particles. It means that the particles that are inside the atoms. What is in the nucleus of an atom? Okay, you have proton plus neutron. Okay, we also revised this in chapter 1 if you still remember. So proton and neutron add up will give you what? Nucleon. Okay, be very sure what is neutron, what is nucleon. What do you think is the charge in the nucleus? Positively charged because your proton is what charge? Okay, proton is positive charge. What about your neutron? Neutral, okay, no charge. What is the charge of your electron? Negative. Okay, is there any mass to your proton? It's considered heavy, okay, around 1. The mass is around 1. What about neutron? Also roughly 1. That is why your proton number plus neutron number, your nuclear number, what is also same as your nuclear number? Atomic mass. You remember what is your atomic mass? Any other name for atomic mass? What do you commonly know your atomic mass as? Molar mass. Where do you get your molar mass? periodic table. Okay? It's all interrelated. That's why you must know what are they. And that's why I'm writing down. Okay? They mean the same thing. Okay? That is why your nucleon number will be the same as your molar mass. And that is why your molar mass is number of proton plus number of neutron. This is to show that each of it has a mass of almost 1. What about the mass of the electron? Is there a mass? Yes. How heavy? Very, 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 very light. Okay, electrons are very light. That is why electrons is the one that can move around. Okay, that can be donated, that can be received, that can be shared. All right. So here, okay, just to show you. All right, so what's the difference between atom and molecules? So atom are the single unit. Molecules are where you have many atoms combined together. Okay, more or equals to 2 atoms. You combine together, you get molecules. Okay, can you specifically tell me molecules are made of what and what? Consist of what? Non-metal and non-metal. What is the type of bond that's being formed? Covalent. Okay, molecules are non-metal, they form covalent bond. Okay, other than molecules, what else you have? What other compounds you have? Ionic compound. So ionic compound is made up of metal and non-metal, so they form what bond? Ionic bond. It looks very simple, but trust me, when you go to chapter 4, a lot of students suddenly they lost all their memories. They don't know what is molecule, they don't know what is ionic compound. All right, so example of molecules, you have chlorine. What is the formula of this chlorine? What do you think? Cl or Cl2? Why cannot be Cl? Because it's molecules. Okay, cannot be Cl. So this is Cl2. What is carbon dioxide? CO2. All right. Okay, so very simple game for you. All right. So you can scan this. Remember to put in your student ID. Very important. Key in your student ID correctly. All right. So this game is for you to drag and drop the characteristics of subatomic particles. For example, proton. What is the charge? What is the mass? Where is it located? What's the function? Okay, most of which we have discussed just now. And neutron, okay, what's the mass? What's the charge? What is the function? And electron. Okay, give it a try. Give you guys around 2 minutes. Remember to key in your student ID. Is my attendance ready? Attendance? Where is it now? When you have the attendance list, okay, I beg you around. You don't hold it. Who else haven't signed? So many haven't signed. Pass it around. I really don't know. You hold the attendance for what? Anyone else still need this QR code? No. Oh, still. Anyone else still need this QR code? For your student ID. Cannot? Can again? If not, you key in the link and see. Zero 087. Who is 087? Okay. 096. 083. Okay, still the same top 3. Just start. Have you tried to? You just key in this one, the ID. Key in the link. Start then. Okay, 54. I actually have 81 students. Oh, 179, new one. 179. Who is 179? Okay, 087 and 115. Where's 115? Okay. 087? Oh, dethroned. All right, enough. Okay, let's discuss on the questions a bit. Okay, so the first subatomic particle, something that's inside the atom. The first one is your proton. So what's the charge of your proton? +1. Okay, each proton has a charge of +1. And what is the mass of your proton? kV. Okay, there is a mass of roughly 1. Where's the location of your proton? Okay, nucleus, and the importance of your proton. Okay, why? Can you explain to me? I briefly talked about this before. Why do we say that proton determines the identity of the atom? Because? Okay, it represents atomic mass. Okay, but the atomic mass is actually what? Proton plus neutron. Any other reason? Why number of proton? Why the proton determines the identity of the atom? It's unique to each atom, okay? If you still remember, I mentioned before, for example, if you look at the periodic table, proton number 6 will always be carbon. If I have proton number 6, it cannot be anything else, okay? So it's like your passport number, it's your identity number, okay? It's unique, okay? It will not change for the same atom. Okay, next we have electrons, okay? The charge of electrons, -1. The mass of electron, virtually 0, because it's very, 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 very light. Location of electrons, outside. Okay, it's not binded in the nucleus, it's outside the nucleus. It's the only thing that is free around to move. What's the importance of the electron? Reactivity. It determines whether it's able to react or not. All right. That is what I meant. Why? Can you further explain to me how does electron determines the reactivity? Under what condition they can react? What condition they cannot react? Or why they react? When they want to form bonds, okay, electron determines reactivity. whether to form bonds or not. Explain further under what situation they will form a bond. Okay, to become stable, what does this stability mean? Okay, either duplet or octet. What is duplet? Two valence electron. What is octet? 8 valence electron. Any bonds that happen, okay, it is to achieve stability. And what is stability? Duplet or octet. Okay, duplet is normally for what? Helium. All right, helium, and then a hydrogen also can. All right, and octet is the rest. Okay, that means my outermost electron, I must have 8. We will revisit this in chapter 4, chemical bonding. Okay, and lastly, we have neutron. What is the charge of neutron? 0, no charge. Okay, what's the mass of neutron? Heavy. So remember I mentioned 1 proton, 1 neutron, all have atomic mass around 2. Location of neutron. Okay, also the nucleus. Importance of neutron to hold the nucleus. Okay, try to explain this. Why neutron is able to hold together the nucleus? What does it mean? The importance of neutron is to hold together the nucleus. Why is it able to hold together the nucleus? It has a glue or what?
Because of the mass.
Okay, because of the mass, there is a mass, so it holds down. Okay, what else? Acceptable. What else? Okay, 0 charge. Okay, what is in your nucleus? You have proton, which is positively charged. Okay, and then you have a neutron. I'll put a neutron here, which is neutral in charge, no charge. All right, so what happened is your neutron, because it is neutral or no charge. All right, what happens if your nucleus only has protons? Attracted. If your nucleus only has protons, what happens if there's only proton?
Maybe like
Repel. Okay, if only proton, what happens if the same charge? Repulsion. Okay, if your nucleus only has protons, they will repel. What happens if your protons repel? What's the meaning of repulsion? Okay, they'll be far away as possible. Because proton, positive, they repel, so they'll be very far from each other. So what happens if you put some neutral charge in between? Okay, it sort of like neutralizes the repulsion. Okay, just imagine, Yongjian and also Jiaxi, they are both positive, very angry with one another, competing with one another. All right, so they're like fighting. So we need somebody in between. So I put a neutron, Kevin in between. Oh, stop, don't fight. All right, we need something in between to stop them from repelling. Okay, so it neutralizes the repulsion. Okay, any questions so far? Good. Okay, these are all actually just basic recap. Let us go through a few more things before I let you guys for a break. Okay, so next we look at behavior. How do they behave in electric field? Okay, electric field. What is electric field? What do you have in an electric? Like in a battery, what do you have? Positive and negative. Okay, you have positive terminal, you have negative terminal in electric. Okay, proton is positively charged and electron is negatively charged. So what do you think will be attracted? Proton will be attracted to what? Negative. Okay, so you can see proton is attracted to negative terminal because proton is positively charged. Opposite attracts. Meanwhile, electron is negative charge. So electron will be attracted to positive terminal. All right, in the electric field. But what's the difference between proton and electron? What do you know just now? The mass, okay? Proton is heavy and electron is virtually zero. And by virtually zero, it means that it is very light. When something is very light, it's being deflected. Deflected means being pushed. When something is very light being pushed, do you think it will being pushed more or less? More. Okay, just imagine a very thin tree, a very light tree. You push it, it will just bend and maybe break. All right, that is why electron being very, very light, it will be deflected more. Okay, meanwhile, proton, a bit heavy, it will be deflected less. Okay, so you can see the angle of deflection. The one for electron will be larger than the proton because electron is lighter. All right, so you can fill in the blank. It's blank in your lecture slides. Ready? Okay, so protons go towards negative terminal, electrons go towards positive. Electrons are lighter, so they are deflected more than protons. Okay, so this question, all the diagram, show the possible deflection of subatomic particles in an electric field. So which of the diagrams are correct? Give you guys 1 minute to go through. Chongjin not here. Muhammad Rizzo. Rizzo. No, no need. You do not need to know the exact mass of electrons. Yes. Nur Sultan is not here. Mahmud Khan is not here. Sava also not here. Ivan, you haven't signed? Kaisa, not here. Peter Mati, also not here. That's to Ivan. Okay, which one is correct? Number 1, is it correct or not? All right, electrons negative charge go towards positive, so this is correct. Number 2, neutrons virtually zero. Okay, zero charge goes straight. Correct? Yes. Number 3, proton positive charge should go where? Down, negative. Okay, so this is wrong. So what's the correct answer? A. All right. So next, okay, symbol of an element. How do we write symbol of an element? Okay, so we have the symbol. Remember, on top is the mass number. Underneath is the atomic number. Can we recap? What is the mass number? What's the meaning of mass number? Okay, it's also same as nucleon number. And what is nucleon number? Number of proton plus number of neutron. Okay, what is atomic number? Number of proton. So between A and Z, which one will have a larger number? A will have a larger number because A is addition, proton plus neutron. Okay, Z is a smaller number. Okay, keep this in mind. Okay, so just now when we talk about the characteristics of subatomic particle, we mentioned proton. Okay, the number of proton represents the identity because it is unique. Okay, it makes the atom what it is. For example, if I have a proton number 11, it must be sodium, cannot be anything else. Okay, so proton number gives you the identity of the element. Okay, so you can also know how many subatomic particles when you know the symbol of the element. For example, I have oxygen. Given the nucleon number 16, proton number 8. All right, so proton number is 8. Okay, the nucleon number is 16. So if it is a neutral atom, proton number 8 was the number of electrons. Same. Okay, because it's neutral. So number of neutrons will be your nucleon minus proton, 16 minus 8. Okay, so do you remember in chapter 1, we also touched that your nucleon number is more or less same as, what is this? Your molar mass or your relative atomic mass. Okay, more or less. You see, it is 15.9994, 16. It's more or less the same. All right, so this molar mass is actually the addition roughly, plus minus number of proton plus number of neutron. Okay, it gives you an idea what is your mass number. Okay, so for negative ion, we also know it as an ion, negative. All right, so proton number will be the same. What about number of electron? You have to start from in neutral. Okay, it will have 8 electrons. But what does it mean to have a -2 charge? Okay, it has additional 2 electrons. All right, so neutral is 8 electrons. So in the negative ion, you will have 8 electrons plus additional 2 electrons. So a total of 10 electrons. And the number of neutrons will be nucleon minus proton. And lastly, we have positive ion. Positive also known as cation, positive. All right, so for example, here I have a positively charged sodium. Number of proton, very direct. You can look from here. So it's the same, your atomic number. Okay, so what does it mean to have a positive charge? So in neutral, I have 11 electrons. But in my cation, what does the positive 1 charge mean? -1 electron. 1 electron is being removed. So from 11 electron, I -1 electron. That's the meaning of positive charge. So I have 10 electrons left. Okay, number of neutron is still the same. Nucleon minus proton, you have 12. Okay, try this. Which isotope in the third period of the periodic table contains the same number of neutrons as sulfur 3216? Okay, try this out. Okay, which one? How many neutrons are there in sulfur 3216? Okay, 16 neutrons. So which of the following also has 16 neutrons? Donkey. Okay, how many neutrons are there in A? 12, B, 12, C, 14. Okay, so just nucleon minus proton. Okay, so this is 16. Very good. Okay, try the subsequent question. I have this until before isotope. Okay, until the hot water. I'll give you guys a 10 minutes break. Coming back, we will discuss on this. It's 9:45. We will come back at 9:55.
Okay.
It's more fun. You need to get it. Not like this. I can eat it. Not still. It's not cheap now. Your campus, your university. You open. No, no, no. They inbox. Have you read it? IPs. Have you read this? Have you read all this? Okay, good number. You have read it. And could you go through this and give it your campus? I think the link is going to be get to okay, we want this. Okay, have to check it email, but everything that we get is info. All right. Now, on the email, this one. Yeah, right. Then kids and different of meetings. Cut down the join the assignment. And show her when to put in the standard in the Microsoft Teams, you know, the Excel. Yeah, so she has to find the group, and then we have to find the leader, how the leader. Okay, find those in 5 minutes. Find those with 5 people. Right. I'm going to oh, sorry, I don't want to. Okay. Oh, you got a new shoes. All right, one more minute. Okay, we will discuss this. Okay, let's discuss your answers. All right. So we're talking about neutral atom. So neutral atom, what does it mean? Okay, proton and the electron will be the same. All right, so it is very easy. You can fill this up. Neutral means you have the same number for this. Okay, how do you find number of neutron? Nucleon minus proton. Okay. So you just minus this. So 51 minus 23, 28, and then 50 and 16. Correct? Okay. Next, okay, deduce the number of electrons in each of these ions. Okay, so normally we start from the neutral. So neutral one will be same as number of proton. All right, so neutral, I will have 19 electron. But now I have a positive charge. What does it mean? Minus 1 electron. So I have 18. Okay, this one I will have neutral. I will have 7 electrons. So minus 3 means plus 3 electrons. I have additional 3 electrons. So I'll have 10 electrons. This I have 8 electrons. So minus 2 plus 2 electrons. I have also 10 electrons. And lastly, I have 31 electron in neutral plus 3 charge minus 3 electron. Okay, it means that I have removed 3 electron. That is why I have a positive 3 charge. 28. Correct? All right. All right. Lastly, okay, just want to check what is the answer you get for this. How many got A? B? C? D? Cannot. How many cannot? Put up your hand. All right. Okay, hot water. Hot water means, okay, if you look at anything that has water, especially the tap, your shower, okay, you'll see a lot of this stain. So all this stain, we call it hot water. So definitely has calcium. That is why you see it's like whitish color. If you're familiar with lime water, okay, the cloudy white. Okay, it has calcium ion and hydrogen carbonate ion from this. All right. How many electrons are present in the hydrogen carbonate anion? What is the formula of your hydrogen carbonate anion from this? You have HCO3 2. Okay, I'm telling you that this formula unit is made up of calcium ion and hydrogen carbonate. What is the formula of hydrogen carbonate? Okay, if this is calcium ion, and this must be your hydrogen carbonate. All right, so HCO3. Okay, what's the charge of your calcium ion? How do you know? Remember the cross-charge thing that we learned previously? So if this has 2, it means this is 2 positive. So what's the charge of this? Okay, 1. Negative or positive? Negative. Okay, this is metal, this is non-metal. So this one has a positive charge, this one has a negative charge. How many positive, how many negative? We utilize the cross charge that we learned previously. Okay, now that you know it is like this, can you calculate the number of electrons? All right, how many were stuck just now because you don't know this formula? I saw only 2 or 3, a handful that answered this. The rest of you, can you try now? All right, the formula is HCO3 with 1 minus. How many electrons are there? So 1 by 1. Hydrogen, how many electrons? 1 electron. Because 1 proton, right? Okay, from the periodic table. Carbon, how many electrons? Hey. 用针线 12. What's the difference between 12 and 6 in carbon? 12 is molar mass. Okay, Newton number. What is 6? Proton number. So you want number of electrons, you get from what? Proton number 6. That's why I say, okay, it seems easy, but students are easily confused. And then oxygen, 3 oxygen. So each oxygen is 8 or 16? 8. What else? Okay, because you have 1 electron, it means you have additional 1 electron. Okay, because I say how many electrons are there in this anion, in this negatively charged. So what do you get? 32. How many got this correct without the discussion? Clap your hand. Okay. Oh, very few. Okay, the selected few. Congratulations. Okay, you should get 32. Unless if you add 12 and 16, then you get it wrong. All right, next, isotopes. Okay, we also discussed about isotopes in chapter 1. What do you remember about isotopes? Same? Okay, same element, but they have different number of, different number of neutrons. Can I reword this something else? Same element also means what? Same? Okay, proton number. Rather than saying same element, you can also say same proton number. Okay, different number of neutrons can also mean what? Different number of nucleon or different mass. Okay, mass number. Okay, I give you alternatives. Means any of these keywords can be considered correct. Okay, so this symbol we have revisited just now. So this is a symbol of the element. All right, so this is the mass number. Mass number means proton plus neutron, and this is the atomic number. I wonder what happened if one day I'm angry enough, I just smash this down. Please, you cannot complain about this because I mentioned before. If I smash it, your phone spoiled, even if it's iPhone 15 Pro, I don't care. All right, you explain to your parents what you use the money for. Okay, so now, for example, I have carbon 12, carbon 13, carbon 14. Can you teach me how do I write these elements? Carbon 12, carbon 13, carbon 14. Where do I write the 12? Top or bottom? Okay, 12, 13, 14. Okay, and then what do I write at the bottom here? This is 6. What about this? 6 or 7? 6, and this is 6. All right, so these are the isotopic symbols, symbols of the isotope. So from here, you can see that what is this percentage referring to? 98.9, 1.1, and less than 0.1. Yeah? Abundance, yes. And what do you know about abundance? What does it show? Okay, how often do you see in nature? When carbon 12 has 98.9%, it means that it is the most abundant. Let's say you pick up one carbon atom, 98.9% it will be carbon 12. All right, understanding the symbol. Okay, so what are the uses of my isotopes? Okay, isotopes can be radioactive or non-radioactive. Some of you will feel that, oh, radioactive, it means that it's going to kill me. Not necessarily. All right, if you want to know, even your bananas that you eat is radioactive. But it takes you a lot of bananas to kill you. All right, so not necessarily. Don't look at the word radioactive and you're very afraid. No need to. All right, so radioactive isotopes, for example, sodium 24, all right, can be used to check for leaks, okay, underground. Because it is impossible for you to keep digging and check whether there are leaks or not. So I run through it, okay, using a machine to check whether there are leaks or not. Because if there are leaks in the pipe, then it's going to explode, all right? So you don't want that to happen. Okay, next, iodine 131. Okay, so thyroid or cancer. Thyroid is something that is near your neck here. Okay, so the function of this thyroid is to digest your iodine. Okay, so it's a hormone. Okay, so what happened is okay, if let's say you have this, you don't have this thyroid gland, you cannot digest your iodine. So they will ask you to swallow one iodine pill. After swallowing, okay, of course you will have iodine here accumulated. They put you inside this machine to scan. Okay, what happens if the iodines are all dissociated, no more iodine? Does it show that you have or you don't have thyroid gland? You have. Okay, because thyroid gland helps you to break down the iodine. So after you eat the iodine, if let's say you don't have it, it means that your thyroid gland is functioning. Okay, let's say you go through this machine and they see that, oh, there is still iodine there. It means that your thyroid gland is not functioning. If it's not functioning, you have to be on medication. Okay, something to help you to break down iodine. Where can you find iodine? Why do you have to break down the iodine? Okay, sometimes in salt you will see iodine. Where else? Don't know. Seafood. All right, when you consume seafood, let's say your thyroid gland is not functioning, you consume seafood, it will accumulate. That's why you have to be on medication. All right. Okay, and lastly, okay, real life application, tritium. What is tritium? Hydrogen 3. Okay, so tritium is used for luminescent. It means a fluorescent light. Okay, so last time for your watches, okay, to glow in the dark, they actually put in paint. Okay, they put paint on the watches so that it will glow in the dark. But now, okay, the more expensive one, if you go to the malls, you will see it's I think around more than 10,000. Okay. Okay, more than 10,000 K, you will see that it's actually, I put in tritium, hydrogen 3, and what happened in the watch is that the hydrogen 3 slowly breaks down. When it breaks down, it will cause to have this glow in the dark effect. Okay, but of course, slowly, it's going to be lesser, not so bright anymore. Okay, what else about hydrogen 3? Okay, how many of you know the recent case of Japan releasing the wastewater? It's also hydrogen 3. Okay, people are afraid because it's a hydrogen 3. Rather than having hydrogen 1, it's actually hydrogen 3. Okay, that's why people are afraid. All right. Okay, write the isotopic symbol for the following atoms. Remember, I showed you how to write the isotopic symbols. So what is bromine 81? Br 81. Okay, and then calcium 44, Ca44. What is iron? Fe 58. And what is palladium? What's the symbol for palladium? Pa, Pl, Pd, P. How many says Pa? How many says Pl? Do you even have Pl in the periodic table? No, no, you don't even have Pl in the periodic table. You guys, So what is it? Pd. Okay, 110. If you don't know, at least you look for 110. Where do you see this 110? Where do you check in the periodic table 110? Do you check it here 110 or do you check it here 110? Position A or position B? How many of you say position A? How many of you say position B? Okay, you understand why position B is a nucleon number, mass number. Okay, you can go until around 110. You will see, actually it's not even 110. 106.42. Okay, roughly. Okay, technetium. Okay, go through this. Give you around 2 minutes. You can discuss with your friends. Then which of the following statements are correct about technetium 99? Okay, is number 1 correct? Haven't. Okay, calculate first. All right, is number 1 correct? Yongjen say no. Some of them say no. Okay, how many of you say number 1 is correct? How many say not correct? Oh, half. Okay, let's check. Technetium 99 is radioactive, has been found in lobster and seaweed. Which statements are correct about technetium 99? So can we complete this first? Technetium 99. What's the proton number for technetium? 43. Okay, so let's see. Proton number 43. Electron number 43. Neutron number 56. Correct? 56? Okay, so it has 13 more neutrons than proton. So I'm talking about neutron and proton. 13 more neutrons than proton. Is this correct? I'll be the few there also. Get it? Alright, so this is correct. Number 2, it has 43 protons. It has 99 nucleons. Yes. What happened? Why did I get this one? Lazy. Okay, you see what laziness has caused you. Okay, you have to count. All right. We are entering a new unit, okay, for chapter 2. Okay, I'll give you guys 1 minute to tidy up your previous notes. Then we continue with mass spectrometer. All right, so learning outcome again, I'm not going to go through. So we will start with mass spectrometer in 1 minute. Okay, we'll have a lot of writings to do, because this is quite theory. All right, so what is a mass spectrometer? All right, so this mass spectrometer is actually a machine. By looking at the name, it means that this machine is going to utilize the mass of the sample that I put in. All right, so spectrometer means it's going to produce a graph. Okay, it's going to come up with a graph utilizing the mass. All right, so what is this? Okay, this machine will utilize mass to charge ratio. May I know mathematically how do you write this? What is mass to charge ratio? What is ratio?
In comparison.
Like this, in comparison. Okay, mass to charge ratio means what? The ratio of mass to the charge. Okay, if you put this in the ratio form, it can also show the same thing. Okay, if you put it in like this, mass over charge, the ratio. Okay, how many to how many? So this is what we mean by mass over charge ratio. And make sure it must be in ion form. Okay, and then we will analyze my sample. So this sample, I will utilize the mass, the weight, okay, and I will be able to determine what is the structure. Okay, let's go into the detail. Okay, so I'm just going to summarize everything in this picture itself. So mass spectrometer, I have 4 stages. The first stage is ionization. What is ionization? What do you understand? Become ion. Okay, I ionize something. So the first stage, the process ionization, it means that I have a sample, I ionize my sample. I make my sample become ion. Okay, but first of all, my sample must be vaporized sample. What is vaporized sample? Gaseous, very good. Okay, first of all, my sample must be in gaseous state first. All right, so this gaseous state gaseous sample go into my mass spectrometer, comes into the first stage, which is ionization. Ionization means I ionize a sample. Okay, the equation for this, I have, for example, a sample in a gaseous state. To ionize a sample, what happens if you watch a Squid Game or if you play this game before? Okay, you have glass beads, uli. Okay, glass beads in a circle. From outside, you throw very hard. Okay, you throw another glass bead inside and you hit this glass bead. What happened to the glass beads inside of this circle? Will be removed. Okay, you arrange all the glass beads in the circle and then from far you just hit. When you hit one of it, it will be removed. Correct? So this is what happened. I have my atom. So my atoms have electron. What happened is I will shoot, okay? I shoot high energy electron into my sample. And what is the purpose? To remove one of the electron. Okay, so I shoot high energy electron. High energy electron to remove, okay, one electron from the sample. So let's say my gaseous sample here, M. How do I write an equation to show that one electron has been removed? I remove one electron, so it's going to form M plus gaseous state. Okay, but in chemistry, do you write minus one electron? No. Okay, we normally write it in such a way that we put it here, so minus will become plus electron. All right, so this will be the equation. M positive gas plus electron. So this is the first stage. Ionization, I shoot high energy electron to remove one electron from the sample. So this is the equation. Okay, next, I move into the second stage. Second stage is acceleration. What does acceleration mean? Increased speed. All right, so I'm going to, here, my ion here, this ion that's being formed will then go through this mass spectrometer. It will be accelerated. The speed will increase. Okay, increase in speed is using electric field. Okay, I use electric field to increase the speed. Why do I want to increase the speed? Because I want to prepare for the third stage, deflection. Remember you learned the word deflection just now? Okay, imagine if you move very fast, you were running, and then I push you. Okay, comparing to another person who is walking stagily, I push that person. Who is easier to fall? The one that walks very fast or the one that walks slowly? Very fast. Okay, the one that's running, if I push, will suddenly fall over. the same thing. Why am I accelerating? So that easier to be deflected. All right, so again, second stage is acceleration. To increase speed, I will use electric field to increase the speed. Third stage is deflection. All right, deflection means I want to push them, deflect them. Okay, so this deflection is according to, remember the word that you used just now, mass to charge ratio. Okay, we will go into this later. What is this mass to charge ratio? And my deflection is by using magnetic field. Okay, acceleration is by electric field. Deflection is by magnetic field. Okay, and the last stage is detection. Detection means I'm going to detect. Okay, detect the signal and I amplify it. Okay, and what's going to be produced? I produce a mass spectrum. Okay, basically what I have underlined here is the summary of what you need to know about mass spectrum. Really, okay, if I come up with a question, explain what happened in a mass spectrometer. Okay, you talk about the 4 stages and you talk about what happened in each stage. You have 4 stages. Each of the stages you talk about 2 things. It's already worth 10 marks. All right, so don't need to, think so many and memorize the sentence by sentence. No, you need to understand what happened in each of that. Okay, I would like to further clarify about this mass over charge ratio. Okay, what is the meaning of mass over charge ratio? For example, I have hydrogen 3. Okay, positive, and I have hydrogen 1 positive. Hydrogen, okay, isotope hydrogen 1 and hydrogen 3. Always remember in a mass spectrometer, only the positively charged ion will be detected. Okay, because your first stage is ionization, you form a positive charge. If it is not positive charge, it cannot be detected. Okay, so back to here. I have hydrogen 3 positive and 1 positive. What is the mass overcharge for this hydrogen 3 positive? What is the mass overcharge? What is the mass? What is the mass? What is the mass? What is the mass of this? Yeah, why got 2 over 3, 1 over 3, 2.5? What are you talking about? What is the mass of this? It is 3, the mass number. What is the charge of this? 1. So what is this value? 3. Okay, so what is the mass overcharge for this? 1, charge 1, 1. Which will be deflected more? A or B? We learned about deflection just now between proton and electron. Between A and B, which will be deflected more and why?
The light one.
How many of you say A will be deflected more? Put up your hand. How many of you say B will be deflected more? Put up your hand. Okay, why B will be deflected more? Lighter. Okay, the same concept we just learned, proton and electron. Electron deflected more because virtually 0 mass. All right, so the same thing. So the one that has a lower mass over charge ratio will be deflected more. Why? Because smaller mass over charge ratio. So introducing to you what is mass over charge. It just means that you use the mass divided by the charge. That's all. And what is the use of this mass over charge? The smaller the value, the more it will be deflected. Okay, give you guys around 1 minute, okay, digest this. See if you have any question. You can tidy up your notes. Okay, trust me, for this mass spectrometer, this alone is sufficient. It's an instrument. Okay, so when asked what is a mass spectrometer, it's an instrument. If you look at this, this is this instrument. All right, you're going to inject the sample inside. There will be the 4 stages. This is what undergoes, and what is going to be produced is a graph. All right, but we're not going to use the instrument, just that we use the theory of mass spectrometer to do calculations. Oh, mass spectrum, okay, is the graph that's going to be produced. Later, you will look at the graph. All right, the charge will always be positive charge. Why will it always be positive charge? Yes, because ionized, I remove electrons. When I remove electron, it will always be positive. Just that sometimes it can be 2 positive or 3 positive, then you have to divide. But 99% of the time, it will be 1 positive. Okay, so always double check the charge. Okay, I'm going to go through the words. Okay, since I have summarized, okay, we go through the words quite slightly quicker. Oh, next time, let's close the door. Huh? All right, so ionization. Okay, what happened in this first stage ionization? Okay, so my sample, okay, is being ionized. How does that happen? I knock electron out with high energy electron. Okay, remember I mentioned just now, I have the electrons. All right, so I shoot with high energy electron to remove 1 electron out. Like I mentioned, 99% of the time, only 1 electron is removed. Okay, but there will be 1% of the time, I will remove 2 electrons, once in a blue moon. Okay, so what will be produced is a positive ion. Okay, so this collision, this knocking, okay, causes the atom, the sample, to lose electron and form positive ion. So this is the sample I gave just now. I have a gaseous sample. I remove 1 electron. 99% of the time is 1 electron. And I form a positive ion. Always positive ion. Okay, so you can see this sample here, bombard with high energy electron, shooting. Okay, like imagine you have a gun. The gun shoots out electron. So you shoot very high energy electron to remove 1 electron out. Okay, you can look at this animation here. You have the electron, you shoot with high energy electron, so the electron is being removed. So this is ionization stage. Second stage is acceleration. Okay, acceleration is to make it move faster using an electric field. Okay, you don't need to know the process, okay, because like I mentioned, we are not using this instrument. Okay, so you just need to know some basic information about this. Okay, so what's the purpose of accelerating? Because I want to prepare my ions for the third stage, which is deflection. So what is this deflection? I deflect using a magnetic field. And this deflection is according to mass over charge ratio or mass to charge ratio. Okay, the lighter the mass over charge, the more they are deflected. For example, I have 20 neon, 21 neon, 22 neon. So of course, the lighter one, which is 20 neon, will be deflected the most. Okay, And then the deflection depends on number one, the mass. Definitely lighter the mass, the more deflected. Number two depends on the charge. Okay, that is why deflection always mass over charge. Okay, give you another example. Hydrogen 1 positive and hydrogen 1 2 positive. Okay, like I mentioned, 99% of the time it will be positive, but 1% of the time it will be 2 positive. Which one will be deflected the most? You can try to calculate what is this mass over charge. 1 over 1. What is this mass over charge? 1 over 2, 0.5. So which will be deflected more? 0.5. Okay, in case the charge is higher, the one with the higher charge will be deflected more. Okay, that is why you must always, for deflection, you must always check the mass over charge ratio. Cannot take for granted, just look at the mass. You must look at mass and charge. Okay, so the lighter one will be deflected the most. The heavier one will be deflected less. Okay, and lastly, we have detection. How is it being detected? Okay, I have a detector that counts. Okay, so what happened? A mass spectrum. Okay, so this will be the abundance. Okay, and this will be the mass over charge ratio. Let's say I have hydrogen 1 and hydrogen 2. Okay, whenever hydrogen 1, I have a sample. Definitely my sample will have many atoms and many ions. Okay, let's say I have 1 gram of hydrogen. How many ions can be formed? You know, 1 gram of hydrogen. How many ions will be there? Cannot twist your mind already. 1 gram of hydrogen. How many moles? 1 mole. So 1 mole, how many ions? 6.02 times 10 to the power 23. Let's say I put in 1 gram of hydrogen. I will have 6.02 times 10 to the power 23 ions shooting inside. Okay, so let's say this 6.02 times 10 to the power 23 ions. Okay, so hydrogen 1. Every time I have a hydrogen 1 hitting the detector, I form a peak. Okay, hydrogen 1. Hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1. Okay, the more hydrogen 1 I have, the higher the peak that's going to be formed. Until maybe it's around 99.9%. And then let's say hydrogen 2. Okay, don't have it suddenly 1 hydrogen 2. So I have a lower peak. This will be around 0.1%. So this is the meaning of the detector counts how many times my ion hit. Okay, impact means hit on the detector. And this will give you the percentage abundance. All right, and the signal is amplified and I produce a mass spectrum. Ladies and gentlemen, this is a mass spectrum. This graph here. Okay, I'll put it neatly here. Mass over charge, percentage abundance. Let's say I have hydrogen 1 and hydrogen 2. So hydrogen 1 higher, 99.9%. Hydrogen 2, 0.1%. So this is a mass spectrum. It shows the mass over charge. It shows the percentage abundance. All right, so here also you have a sample of a mass spectrum that's going to be produced. Okay, so what happened, okay, let's say to the other ions that are not detected, okay? So remember at the beginning, they have these gases forming a positive ion plus electron. So any ions that are not detected, they will just pick up the electrons and they neutralize and remove by a vacuum pump, that's all. Okay, those that are detected, they will hit and form a mass spectrum. Okay, so this summarizes the mass spectrometer. Can only detect cations and must be according to mass overcharge ratio. Okay, so here positive ions are detected, others they are not detected. All right, so I think we will continue in the next class. Okay, what's going to be produced from a mass spectrometer? So we will stop here. If you have any question, okay, feel free to text me in Microsoft Teams. Okay, before I let you guys off, remember today we have replacement for tutorial 3 to 4, FIS 1 and FIS 2 combined. Okay, and then tomorrow we will have lab replacement. Okay, please refer to the announcements, yeah. Actually, I will post everything in Microsoft Teams. And also, I have also posted how to use Turnitin. So to those of you who have started your assignment, okay, please go through this. All right, so if no question, then that's all. Thank you, class. I'll see you guys this afternoon.